So we've been learning about right triangles, and I mentioned earlier that we're going to have to use trigonometry to be able to find missing sides of right triangles. So today's video is going to talk about specifically trigonometric ratios that are going to be useful. Now, why do we ever study trigonometry? Well, we know how to find the lengths of sides of a right triangle when given two lengths of the legs, or when we have special right triangles such as the 45-45-90 or the 30-60-90 triangle. But what about all those other possible right triangles? Right triangles are very useful for solving real-world examples, so we need another way to solve for the lengths of the sides or the angles when we do not have these situations. We need trigonometry. Now, to help us understand trigonometry, we're going to hear about the legend of SOHCAHTOA. So sit back, relax, and we're going to have a little story time. So many moons ago, in Archimedes Forest, lived a young Indian girl named SOHCAHTOA. As with all Indians of the Trigorian tribe, SOHCAHTOA derived her name from a memorable event in her early childhood. One day her father noticed her sitting on a natural log, dangling her feet in the water and solving problems involving right triangles. He cleverly declared her name shall be SOHCAHTOA, and the name stuck. SOHCAHTOA studied for many years and became very proficient in mathematics. She probably would have become a famous mathematician if she hadn't discovered boys, especially Falling Rock. SOHCAHTOA liked Falling Rock and convinced him to study mathematics with her. After a while, he got bored and said, "I like angles to a degree, and I feel positive about whole numbers. I'll even do some addition. However, I feel the inverse of multiplication causes division, and I'm totally confused when you say pies are squared. Nevertheless, graphing is where I absolutely draw the line." Right before Falling Rock turned 18, he asked SOHCAHTOA to marry him, and she agreed to be his bride and put her studying aside. But before they could wed, Falling Rock had to pass the trials of manhood. Every boy in the tribe had to complete this ritual to be deemed ready for the responsibilities of marriage. Tasks were uniquely created for each individual, and Falling Rock's task required him to travel to Triangle Mountain to put ink on the tail of a parrot that sits at the peak. When Falling Rock and his tribe arrived at the base of the mountain, the elders supplied him with a few cooking utensils and a jar of ink for the parrot's tail. He bid them farewell and spent many days in the sun, becoming quite the tangent on his way to the peak. That was the last time anyone ever saw him. After a few weeks, SOHCAHTOA decided to go up the mountain to find him. A few thousand feet up, she found her lover's cooking utensils sitting over a fire. The high pot was in use, was a sign that she was on the right side of Triangle Mountain. She climbed to the top, but she didn't find the parrot. However, she did find a message written in stone. Her mathematical sense found it ironic that on the stone at the peak of Triangle Mountain were the words, "Polygon." SOHCAHTOA descended the mountain and never gave up hope that she might find her lost love. Even to this day, it is said she is still looking for him. In fact, you can still see the signs SOHCAHTOA left on the sides of the roads of the mountain. Watch for Falling Rock. Now, we need to remember SOHCAHTOA when we talk about trig ratios, because her name represents the ratios of trigonometry since she was a strong mathematician. SOHCAHTOA, if we think about her name, SOHCAHTOA, is going to help us remember our trig ratios. The first trig ratio is called the sine, and the sine is represented by the opposite side of the triangle over the hypotenuse. The second one we're going to learn about is the cosine. The cosine is represented by the adjacent side of the triangle and the hypotenuse. The last one is the tangent, represented by the opposite side of the triangle over the adjacent side. And SOHCAHTOA's name spells out these ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, what does this actually mean in terms of a triangle? Well, we find the sine of an angle, so we're going to say sine of angle A, this is angle A, is opposite over hypotenuse. So the side opposite is x over the hypotenuse z. So the ratio of the sides is x to z. The cosine of angle A then is the adjacent side, or the side next to angle A, over the hypotenuse, y over z. And the tangent of angle A is the opposite, which we already decided was x, over the adjacent, y. So the ratio for the tangent of angle A is x over y. Now, I want you to find the sine, cosine, and tangent of angle B. The sine of angle B is the opposite, which is now y, over the hypotenuse, which is still z. The cosine for angle B is the adjacent x over the hypotenuse z. And the tangent is the opposite y over the adjacent x. Now we're going to actually use this with numbers, and maybe it'll make a little more sense. I know this is still kind of an abstract concept. So let's look at this in terms of numbers. The sine, cosine, and tangent of angles N and O is what we're going to find. We can't find the sine, cosine, and tangent of angle M because that's our right angle. We're always looking for the angles that are not right. So let's start with the sine, cosine, and tangent of angle N. So the sine of angle N here, the sine of angle N is 5/13. The cosine is 12/13, and the tangent is 5/12. Angle O, the sine is going to be 12/13, the cosine 5/13, and the tangent is 12/5. Your turn. I want you to find the sine, cosine, and tangent of angles X and Z. The sine of x is 8/17, the cosine is 15/17, and the tangent is 8/15. The sine of z is 15/17, cosine of z is 8/17, and the tangent is 15/8. Now how does this actually help us? So let's look at an application. When are we going to use this? And how does this, or what does this tell us? So, a section of Filbert Street in San Francisco rises at an angle of 17 degrees. If you walk 150 feet up, what is your vertical rise? So here's our diagram, because we haven't talked a lot about angles of elevation yet, and we will. We're going to say our angle here is 17. We walk 150 feet up Filbert Street. We want to know how far do we actually go up. We're going to use a right triangle because we're looking at vertical distance. So, if we look at the sides we have the opposite and we have the hypotenuse. So we want to use the trigonometric function of sine. So the sine of angle 17, or sine of 17, is the opposite x over the hypotenuse, 150, x over 150. Now what this tells us, if we multiply both sides by 150, we get 150 times the sine of 17 is going to give me x. Or x is 38.3, so the actual distance you rose was 38.3 feet. Now, if you're having a hard time finding these functions within your calculator, please ask in class, and I will help you find them. A lot of times they're in a button that's trig, T-R-I-G. Sometimes they're directly on your calculator. But you're going to want to type in 150 sine 17, and that will give you x is 38.3 feet. Now, we also use inverse functions, and we use these to find missing angles. Think of an inverse function as a function that reverses the trigonometric function. So we use the trigonometric function to find side lengths. When we reverse it, we can also find the angles. So the function sine of A, the inverse is going to look like sine, but it's going to have a -1, meaning it's the inverse. and each of the three functions that we've talked about have an inverse. We use these to find the measures of angles. So if we want to find the measure of angle x, we can say that we have the 6 is the opposite, 10 is the hypotenuse, so we want to use a function of sine. So the sine of x is 6/10. This is what we started the video with. To find the angle measure, we need to use the inverse function, which you'll find in the same location as your button as the regular function on your calculator. So we would type in the inverse of sine, and then we put in the fraction 6/10, or the ratio 6/10. That tells us that angle x is 36.8 degrees. To find the measure of angle C, well, let's think about C. We have the adjacent and the opposite, or the hypotenuse, So when we have the adjacent and the hypotenuse, that tells us we need the cosine. So the cosine of C is 15/20. So to find the value of angle C, we're going to use the inverse function, or cosine to the -1 of 15/20, which tells us angle C is 41.4 degrees. Find the measures here of angle D and angle X. Pause the video and give it a shot. Angle D, we're going to use the sine function, which is 12/18. So the inverse sine of 12/18 is 41.8 degrees. For angle X, we're going to want to use the tangent function because we don't have the hypotenuse. Tangent of X is 100 over 41. So the inverse tangent is 100 over 41, or 67.7 degrees. And I know we had a lot of information, but that's the end for today. Please bring your questions to class, and we are going to review this in class.